Okay, next one introduce you A complement. The complement of an event A is a set of all outcomes in the corresponding sample space that are not contained in A. Okay? This is A complement. What is A complement? A complement is we remove what? A from the corresponding sample space. Okay? A complement is that we removing what? We remove A from the corresponding sample space. Okay? For example, E4 complement. What's E4? E4 is that we see what? A head on the first flip of random experiment 1. So, what is E4 complement? E4 complement is S1. From what? S1, we remove E4. Okay? We remove E4 from S1. We remove E4 from S1. And what's S1? S1 is resulting from random experiment 1. The sample space resulting from what? Random experiment 1. And S1, as you see this before, S1 consists of 4 possible outcomes. Head-head, head-tail, tail-head, and tail-tail. So E4 is head-head, head-tail. So we remove what? Head-head, head-tail from S1. So we have only what? 2 outcomes left. And that is tail-head and tail-tail. Okay? Similarly, you can find what? E5 complement. However, here, I'm not going to use this approach again. I'm going to use a more directly way. Use a definition. Remember, what is E5? E5 is in random experiment 1, we see what? A tail on the second flip. So the complement is we see what? Not a tail, we see what? We see a head on the second flip. So on the second flip, we see what? We see a head. As for first one, is what? It can be head or tail. Okay? Now, if you are not so comfortable about this, well, you can use the definition again. Okay? You can use the definition again. The definition says, what's E5? E5 is on the second flip, we see what? We see a tail. As for first one, it can be either a head or a tail. So we remove head tail from S1. Head tail, remove this. And remove what? Tail tail. So what's left? Well, only 2 possible outcomes left, right? Now 2 possible outcomes is head head, which is this one here, and the other one is tail head, which is this one here. Okay? Now, a very important rule that regulates complement operation is called the De Morgan's law. And what is De Morgan's law? Look at here. De Morgan's law says A or B complement, when we remove the bracket, it becomes A complement and B complement. However, the O need to be changed to what? N. Rule 2. A and B complement, if we remove the bracket, it becomes A complement, B complement. However, the intersection changed to what? Changed to union. I'm not going to give what? This is a very rigorous proof. However, I'm going to show you by a very simple example and verifying why the De Morgan's law is what? Is right. Okay? So we are going to verify the De Morgan law through the following example. Now, look at here. E4 complement and E5 complement. Okay? As we just found here, E4 complement, E5 complement. E4 complement and E5 complement, looking for the common outcome. Okay, looking for the common outcome. So let's look at here. E4 complement, tail, head, tail, tail. E5 complement, head, tail, tail, head. Do they share anything in common? Answer is yes. They share what? Tail heads in common. Okay, they share tail heads in common. So E4 complement and E5 complement is what? Is tail head. Now, if I use De Morgan's law, what should I do? Well, from De Morgan's law, from De Morgan's law, okay? From the De Morgan's law, I have what? I have E4 complement. If I remove the bracket, okay? E4 complement, E5 complement. And all become what? And all become N. And as I show you here already, E4 complement and E5 complement is just what? Tail head. Okay? Now, by definition, what is E4 or E5 complement? Well, is that we remove what? E4 or E5 from the corresponding sample space. And the corresponding sample space is what? Is S1. And what is S1? Let's see, what's S1? S1 consists of 4 possible outcomes. Head, 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 tail, tail, head, and what? Tail, tail. And what's E4 or E5? E4 is or E5, as we mentioned before, is head, head, and head, tail. These two come from what? E4. And the two come from E5 are head, tail, and tail, tail. Because this one repeats, so we don't need this one. Now, next. Sorry, okay? Now, next, we remove what? Head, 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 tail, tail, tail from S1. Head, head, removed. Head, tail, removed. Tail, tail, removed. So what's left? Well, we have only one what? Outcome left. And that is what? That is tail head. Okay? So you see tail head here. You see tail head here again. Okay? So this is a quick what? Quick way to see why De Morgan's law is right. Okay? Next topic. Next topic. Next topic. Let's look at a Venn diagram. Let's look at a Venn diagram. A Venn diagram is a pictorial representation of what? Events. Okay? if we use what? The rectangle to represent the whole sample space. Okay? Well, actually, you don't need to put a rectangle. You can put any shape you like. Okay? And same thing for what? Event A and event B. If you like, you can even put like this way, right? You say this is my sample space, and this is B, and this is A. That's fine too. Okay? That's fine too. Now, let's look at the first picture here. The second picture here. Okay? Tell me, what is the shady area? If I tell you this sample space, and this circle represents A, this circle represents B. And the shady area here is their common area. Okay? So this shady area is in A, also this shady area is in B. So this shady area is what? Is A and B. Okay? It's in A, also in B. Now let's look at the next one. What is a shady area? If the whole rectangle represents a sample space, and this is A, and this is B. Now, how we say the whole what? Shady area? What do we say about this shady area here? Well, you can see everything in A is included. Everything in B is also included. That includes also what? The common area, A and B. So this is what? This is A or B. Okay, this is A or B. Next one. Next one. The rectangle again represents what? The whole sample space. And this is the event what? C. Okay? But what is the shady area? The shady area is what? The shady area, well, probably this C make me a little bit awkward. So let me change to what? Let me change to A. And I put shady area here. Okay, I put shady area here. So this is everything in the sample space, but I take A away. So this is precisely the definition of what? Of A complement. Okay? The shady area represents A complement. And this is a very interesting picture, because from this picture you can derive two properties very quickly. You can see, okay? You can see A and A complement. They share nothing in common, okay? However, if you put them together, A or A complement, they give you what? The whole sample space. So this picture is very interesting, okay? Now, the last picture here. This one is a little bit harder, okay? And a little bit harder. Now let's look at here. The shady area here is not the whole B, because this area is what? Is gone, okay? This area of B is gone. So how we represent the shady area? Well, the shady area is, you can say the shady area is what? From B we take what? We take what? We take A and B what? Away. This is easy, okay? The harder way to see it is what? Is B and A complement. So try to convince yourself these two are what? Are the same, okay?